Hello, welcome to this session in the Internet Study Mate series. In our previous meeting, we started with reflection, and we said that reflection is a phenomenon whereby a light ray bounces on a surface after it strikes that surface. It bounces back. And then we also said that there are two types of reflection: the one that occurs on a smooth, shiny surface, and the other one that occurs on a rough surface. We said that the one that occurs on the smooth, shiny surface is known as irregular reflection. And in that type of reflection, parallel rays are reflected in the same direction. When it comes to the one that bounces on a rough surface, it is known as irregular reflection, and in that case, parallel rays are reflected in different directions. We also dealt with the laws of reflection, and we said that one law of reflection states that the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. And then the other law states that the angle of incidence is equal to the angle of reflection. Today, we are going to continue with the formation of images. Formation of images. Generally, images are formed by mirrors. Yes, generally, images are formed by mirrors and lenses. Mirrors and lenses. And well-defined images are actually formed by smooth, shiny surfaces. So, we have two types of images. Before we deal with the formation of images, it is important to know that we have two types of images. One is a real image. And then the other one is known as a virtual image. These are the two types of images. And we want to see the difference between these two types of images. One is that a real image can be projected on a screen, but a virtual image cannot. Secondly, images formed by real images are inverted. Virtual images, however, are erect, or they are upright. Real images are formed at a point where light rays meet. When it comes to virtual images, they appear to form from a point which does not exist. And then, real images are formed in front of the mirror, while virtual images are formed behind the mirror. So these are the differences between real images and virtual images. So we want to see the formation of images the formation of an image by a mirror. In the diagram we have on the screen, we see that we have a reflecting surface. So we have a reflecting surface and then an eye of an observer here where the pointer is. So let's see what happens. We have an object from which light rays travel onto the surface of the mirror. And what we see here, the light rays are actually reflected according to the laws of reflection to the eyes of the observer. But then behind the mirror, we see broken lines which represent the how the light rays would have traveled to where we have the image. This is where the image is, and the image, if you can see it well, is also represented by broken lines. So this is how images are formed by plane mirrors, and there are characteristics of images formed by plane mirrors. We want to look at these characteristics. One, the image formed is upright. The image formed is upright. It is not inverted, it is upright. And then two, the size of the image is the same as the size of the object. The size of the image is the same as the size of the object. 3. The distance between the image and the mirror is equal to the distance between the object and the mirror. So we say that the image is as far behind the mirror as the object. We can also see that the image is laterally inverted. The image is laterally inverted. Then the image is virtual. Why? Because it is behind the mirror. Then we can also say that the image is on the same normal as to the mirror as the object. What it means is that if we draw a perpendicular line to the mirror from the object, it is also going to pass through the image. So these are characteristics of an image formed by a plane mirror. Alright, then we move on to curved mirrors. Curved mirrors. Curved mirrors are also known as spherical mirrors. They are also known as spherical mirrors. It is assumed that curved mirrors are actually cut from a spherical mirror. And there are two types of curved mirrors, as we can see on the screen. We have one that is curved inwards, where the surface of the mirror is inwards. So here, that red curve we see here represents the surface of the mirror. That's smooth, shiny surface of the mirror. And then we have another one where the smooth, shiny surface of the mirror is outside, is curved outwards. The one with the smooth, shiny surface inwards is known as a concave mirror or a converging mirror. Then the one with the smooth shiny surface outside is known as a convex mirror or a diverging mirror. Very soon we are going to see why they are known as converging and diverging mirrors respectively. So there are two types of curved mirrors. We have the concave mirror, which caves inwards, or it caves in. The smooth shiny surface is inwards. And then we have the convex mirror, where the smooth shiny surface is on the outer surface. We'll realize that in the concave mirrors, parallel rays that strike the mirrors are converged in the center of the mirror. So as we can see in the PowerPoint, let's go back and observe it again. when parallel rays fall on a concave mirror, the rays are reflected inwards. Therefore, they converge at a point. That point is known as the focal point. When it comes to convex mirrors, when parallel rays strike the surface of a convex mirror or a diverging mirror, the rays are reflected outwards and therefore are diverged. Here, sorry for some of the arrows which are a little bit displaced. So this is how a convex mirror behaves when parallel rays strike the surface. So these are the differences between a concave mirror and a convex mirror. Now, we are moving on to parts of a concave mirror. Parts of a concave mirror. So this is a concave mirror. The green curve being the smooth, shiny surface. Now, in the mirror, we have line AB. That line is known as the principal axis. The principal axis. Then we have a point F. Point F represents the principal focus, also known as the focal point. So, in a concave mirror, that is where parallel rays will be reflected to, or that is where all parallel rays, when reflected, will meet. After the point F, we have another point C. That point C is known as the center of curvature. That is assumed to be the center of the sphere from which the mirror was cut or removed, or the center of the sphere from which that segment of the mirror was cut. From the center of curvature to the edge of the mirror, or the vertex of the mirror, also represented by V, the distance is known as the radius. The radius of curvature. Alright. So, what is the focal point? The focal point, or the focal length, which is from the vertex to the focal point. The focal length is half the radius. So this means that R is equal to 2F. 2 times the focal length will give us the radius. That means that the focal point is between the vertex of the mirror and the center of curvature. Okay, so now that we know the parts of the concave mirror, let's move on. So, let's go over the parts of the concave mirror. We have the principal axis, which is line AB. That's the main line drawn through the mirror, and it divides the mirror into 2. We also have the principal focus, also known as the focal point. And then between the mirror and the focal point, we have the focal length. The focal length is half the radius of the mirror. It's half the radius. And the radius is the distance between the center of curvature and the vertex of the mirror. Okay, now we are moving on to the ray diagram. where various images depending on the position of the object are formed. Before we move on to the ray diagram, or as we go through the ray diagram, it is very important for us to know three facts that govern the ray diagram. There are three facts that govern the ray diagram. So if you are drawing a ray diagram, you need to consider these three facts, and these three facts are going to help you to draw a proper ray diagram no matter the position of the object. Okay, so fact one states that any ray that is traveling parallel to the principal axis will pass through the focal point upon being reflected by the mirror. Any ray traveling parallel to the principal axis will pass through the focal point upon being reflected by the mirror. So that is fact one. The second fact tells us that any ray that passes through the focal point, will travel parallel to the principal axis upon being reflected by the mirror. Thank you. So fact 2 states that any ray that passes through the principal focus or the focal point will travel parallel to the principal axis upon being reflected by the mirror. Let's take note that all these types of reflection follow the laws of reflection. Fact 3 tells us that any ray that passes through the center of curvature will be reflected back along the same path upon being reflected. Any ray that passes through the center of curvature will be reflected back along the same path. So these are the three rules governing the ray diagram. Alright, time is not on our side, so we'll have to do a recap of the rules governing the ray diagram. The first rule says that any ray that is traveling parallel to the principal axis will pass through the focal point upon being reflected by the mirror. So this is it. The blue line you see here talks about the first rule. So this ray is traveling parallel to the principal axis and has been reflected through the principal focus. Then the second rule tells us that any ray that passes through the principal focus will travel parallel to the principal axis upon being reflected by the mirror. So this is the second rule that is represented by the magenta color. So this ray travels through the principal focus and has been reflected parallel to the principal axis. The third and the last rule tells us that any ray that travels through the center of curvature will be reflected along its own path. So this is the ray that travels through the center of curvature and then is reflected back along its own path. Thank you for listening to this session. Don't forget to send me any question on your mind, any question that boggles your mind concerning this session, to the email I gave you, to the email address I gave you in the previous session. For those who may forget, it's gkimbia@hotmail.com. gmail.com.